Hi everyone, my name is Miss Hu and I am a physics teacher. In this video, I am going to show you how to solve problems involving objects on an incline. Now, when you have an object sitting on an incline, you must understand that the object is going to slide down because of its weight. So I know it's a little bit drunken here, but I can't use the square function because I can't rotate it. Okay, so let's just go with it, all right? Okay, so for the purposes of this example, let's keep this a smooth surface first because I'd like you to learn the concept of resolving forces for this object before we get to considering frictional forces in our problem solving, all right? Okay, so we know that the object is going to slide down the incline. And bear in mind that the angle of incline is important because the greater the incline, the greater its acceleration is going to be as it slides down. Think about it logically, right? If the incline is not very steep, the object won't slide down very quickly. The greater the incline, the faster it's going to slide down. It's like how you guys, if you love to sit on the slides, especially on water slides, and you find that, okay, it's very gentle, meh, but if it's a greater, for you adrenaline junkies, you're going to love it so much. So which means that the angle of incline does play a role in terms of how the object is going to accelerate. So I'm going to label the angle here, theta. So next time you see an object on an incline, how do you solve the problem? Here's a shortcut. Next time you see it, just take your pencil and draw an arrow in this direction downwards and just label it as W sine theta. W sine theta is the value of the force making the object slide down in this direction. So if you have any forces acting in the opposite direction, for example, if you have a pulling force upwards, what you do is you just take this value of force and minus W sine theta. So that's a shortcut. But of course, if you're wondering, okay, how did we get this W sine theta in the first place? Let me show you. Now, for the next part of the video, you don't need to prove or derive W sine theta. You will not be asked this in exams. However, I believe that knowing how W sine theta is obtained will help you understand this concept better and also enable you to answer the questions better with more understanding. So what I'm going to do now is I'm going to draw a larger incline so that you can see what I'm drawing more clearly. Okay, I'm just going to complete this like so. Okay, let's try not to make the box so drunken. So let's just keep this a smooth surface to make this easier. But we're not going to bother about the friction on the surface. We're going to find out how W sine theta is derived. Now, as you already know, what makes this object slide down is its weight. The weight line is always going to act downwards towards the center of the earth. So I'm going to label this as weight. Now, if the object is going to move in this direction, you need to find the force that's acting in this direction. And what you need to do is you need to resolve the forces. If you don't know how to resolve the forces, please watch my video on force resolution because you need to have that basic before you can understand this example. Let's do a quick recap of force resolution. So I'm just going to remove the arrow. Now, when you want to resolve forces, the force is always given to you at an angle like so. And when you resolve them, what you need to do is you need to find the horizontal and vertical components. So I'm going to label this as Fx and Fy. If you recall, Fx is actually F cos theta and Fy is actually F sine theta. So this is the concept of force resolution. And what you're going to do is you're going to resolve the weight line just like this. However, be careful. You cannot just take a random triangle like, oh, okay, I've got a triangle. Oh, look, I have a triangle here. And you take this triangle to be your force resolution triangle. You cannot do that. Why not? Because if you look at this force resolution triangle, you can see that F is actually the hypotenuse. Fx and Fy make up the perpendicular lines. In this triangle, you'll find that weight is one of the perpendicular lines. You cannot have that. Weight must be the hypotenuse. So which means that you have to resolve weight using this method, but weight will be your hypotenuse. How are we going to do that? Okay, let me show you. So how do we do this this is the start, this is the end, just like this, start and end. Starting from here, you need to draw a line that is parallel to the surface because this is the direction of motion. This is the force direction you need to find. Then from the tip of the arrow here, you need to draw a line that is perpendicular to this blue line. That means if you look at it, this is not perpendicular, neither is this perpendicular. So make sure that you get the perpendicular line, like so. If you have excess, then just erase it. That means this and this, these two are the components of the weight line. So I can't label this as X and Y because they're not, parallel to X or Y axis. So I'm just going to label this as W1 and W2. So in order to find the value of the force that's making it slide down this way, that would be W1. But how do we find W1? Right, so now we're going to look at the whole triangle again. So the question only gives you the value of theta. How does theta apply to our weight triangle? Okay, bear with me. We're going to do a series of triangular understandings. Let's use black. So let's look at this triangle first. So you got theta. Okay, and of course you got this big triangle. Let's not look at that. Let's look at the red line now. So we've got this small triangle. Can you see? This is theta and this is 90 degrees. That's between the red and green line. So if this is theta and this is 90, let's figure out how much is this angle worth. Calculate it. See. So remember that the sum of the internal angles of a triangle is 180. So 180 minus 90 minus theta, you can express this as, I'm going to write it on the outside here, 90 minus theta. So I'm writing it on the outside to keep the inside clear because we're going to do more labeling on the inside. So if this is 90 minus theta, and you find these two lines are parallel, using what you understand about parallel rules, that means this angle is also 90 minus theta. Now let's look at the red and blue triangle. So you've got the red and blue triangle here. This, as we know, is perpendicular to each other. So if this is 90 minus theta and this is 90 degrees, we need to find the angle here. I'm going to erase this so that it doesn't confuse you. Otherwise, it's just too many labels in the same location, right? So we need to find out the angle here. Think about it now. 90 minus theta, 90. This is like this, 90 minus theta, this is 90 plus theta, which means that this is, that's right, this is theta. So what we've proven here is that if this is theta, this will be theta no matter what. So that means if this was 30, this will be 30. If this was 45, 45. If this was 22.325, this would be 22.325. So whatever the angle of theta is over here, this value will be exactly the same. How do we use this to find W1? Remember, our focus is W1 because that's the force making the object move in this direction. So looking at theta now, the weight line is our hypotenuse. This W2 is our adjacent, and this W1 is our opposite. Try to recall, which trigonometry function relates opposite with hypotenuse? That's right, sine. I'm going to switch to black. So sine theta equals to opposite over hypotenuse, which is W1 over weight. So how do you find W1? So W1, by bringing W up, you would get W sine theta. And that's why I mentioned earlier, you just need to use W sine theta as your shortcut. So here's an example of a question you may come across. For example, you could have a situation like this, where they give you the mass of the object, say it's 2 kilograms. Say they give you the angle here, let me change color, say to 30 degrees, and they give you the value of the friction as well. They say, okay, the friction acting on the surface here is 5 Newton, and it could ask you to calculate the acceleration. So if you have to solve it, you're like, okay, where do I get started? You don't have to draw that entire triangle as you saw in the previous slide. An easier way is just to use the shortcut of W sine theta. So remember, I said take a pencil, use the green color in this case. Just label on the diagram with your pencil the arrow with W sine theta. And this will remind you that the value of the force acting in this direction is W sine theta. Now, assume that it's going downwards. So the friction here is 5 Newton. So to solve this, you would use F equals MA, where F is your resultant force. So you'll have W sine theta minus friction equals to MA, where FR is the friction. So W is what? Your mass, right? So mass is 2 times G 9.81 sine 30 degrees minus 5 equals to 2A. Using your calculator, you would get 4.81 equals to A. When you solve this, you would get 2.405 meters per second squared. And it's acting in this direction. That means it's heading down the slope. And that's how you solve questions involving objects on an incline. Now to end this video, I would like to just complete this video by talking about W1 and W2. We have already seen in the earlier part of the video how we derived W1. I will go through that again as well as show you how to derive the value of W2. We know that if the angle of the incline is theta, the angle of this triangle at this point is also theta. Based on this angle of theta, the weight line is the hypotenuse, W1 is the opposite, and W2 is the adjacent. Using our understanding of trigonometric functions, this is how we have obtained. Let me change the color. Let's put blue. This is how we know that if we want to find W1, which is our opposite, and the weight value, which in this case is the hypotenuse, we can use sine to find the value of W1. Sine is opposite over hypotenuse, so that's how we get W1 over W, and by bringing this up, we can solve it as W1 equals to W sine theta, as we saw in the earlier part of the video. We have also seen how to solve problems about the motion of the object along the inclined plane by making use of the value of W1, which is W sine theta. Now what about W2? W2 should not be neglected as well. Let's just go through how to derive the value of W2. I'll change color here just to make this easier to differentiate. The trigonometric function that relates the adjacent to hypotenuse is cos. So cos theta, which is adjacent over hypotenuse, in this case it will be W2 over W. So to derive the value of W2, you would get, bringing this up, W cos theta. So what is the purpose of knowing the value of W2? Why do we need to know this? So when you look at the object that's placed on the surface here, recall what you have already learned about the concept of reaction forces. A reaction force is a force that is acted upon the object by the surface that it is sitting on. Normally, the object is exerting weight on the surface. So the surface would react by applying a force that is normal or perpendicular to its own surface onto that object. So which means that in this case, because there's weight acting on the surface would apply a force that is normal or perpendicular to the surface. So the green line I've just drawn here, this is the normal reaction. The normal reaction in this case is not equal to the value of the weight because as you can see, the forces are not parallel or in the same direction. So in order to find the value of the normal reaction, we need to find the force line that is parallel to its direction. And as you can see from the triangle over here, W2 is parallel to the normal reaction. And yes, it's in the opposite direction, which totally makes sense because the normal reaction has to react in the opposite direction to the force that's being applied on it. So based on this diagram, you can see that the value of the normal reaction is equal to W2, which in this case is W cos theta. So this is what you need to be aware of as well when you want to solve problems involving objects placed on an inclined plane. I hope you have found this video educational and helpful. Don't forget to click like and click subscribe to my YouTube channel, Physics Rocks. Thank you for watching and happy studying.